Okay, y'all, test tomorrow. It's a cubic cube root test. We're going to review today. I'm sorry, I'm going to move my stuff. Okay, so first things first, section 1 is 1 through 6. We're just graphing. So I'm going to type this in. Okay, sorry, getting all situated. X plus 2 to the third power plus 4. Okay, I just typed it just the way I see it. Remember, this thing right here is what goes up for the 3. Okay, and we're going to find points that we can actually plot. So remember, it's negative 10 to 10, so anything between negative 10 and 10 here, these are all between negative 10 and 10. So negative 4, negative 4. Negative 3, 3. 1, 2, 3. Negative 2, 4. Negative 1, 5. And then 0, 12 is going to be like way up here somewhere. Okay. Okay, so let's look at number 2. Now, number 2 has a fraction, so guess what? You're going to have to plot a fraction. I like to do it as a decimal, though. If you ever don't know, you can just do divide, and it'll tell you what the decimal is. So if it's like 2/3 or something, that may get a little harder. You can't really do a third, but any pretty decimals you can do this way. I like to type it as a decimal because decimals are easy to tell where you're graphing. So x plus 4 to the third power. This is the only time you'll have to plot a non-fraction, or a fraction, sorry. It's the end of the day, Valentine's Day. My mind is gone. Okay, so again, finding points we can plot. So we're going to start here at negative 6, negative 9. Negative 5. Negative 5.5. 1, 2, 3, 4, 5.5. Negative 4, 5. Negative 3, 1, 2, 3.
Okay, Eagle, that was 255.
4.5.
This time you should already be in the classroom with the teacher, sponsor, coach,
and negative 2,
or
1.
outside waiting for a ride. After this time, you need to have a pass to be in the hall.
So here is your graph. Alright, so let's look at number 3. Negative x to the third power plus 1. Again, finding our pretty points. So here's a 9. We can plot those right here. So negative 2, 9. Negative 1, 2. 0, 1. 1, 0. And 2, negative 7. Okay, let's look at 4 through 6, which are cube root. So remember to type cube root. To get this, you type math 4 in your calculator. So everybody look. Math. Oh, here, let's clear this. Math, and then I type the number 4. There it is. X minus 5 plus 2. Second graph. So now is a little weird. I always start with x is negative 10, and I look for pretty points between there and positive 10. So negative 3, 0. Here's more. 4, 1. 5, 2. 6, 3. And then the next point is pretty far out there, all the way at 13, 4, so it's going to be like way over here. So it's going to look like this. Okay, obviously if you didn't do this, that would be fine. Just make sure, like I've had a lot of people try to draw like exponential where it goes up. Just remember, after the 3 clutters, it kind of straightens back out. So let's try number 5. Math 4, negative x outside minus 4. So again, I start at negative 10. So I have negative 8, negative 2. Negative 1, 3. Negative 3, sorry, negative 1, negative 3. Zero, negative 4. 1, negative 5. And 8, 6. Negative 6. Okay. Let's look at number 6. Negative 2, math 4, x plus 1, outside minus 5. Start at negative 10. So negative 9 is negative 1. Negative 2, negative 3, negative 2. Negative 9 is 1. Yeah, I'm just making sure I did this right, sorry. Negative 1 is negative 5. 0 is negative 7. And then we get 7, negative 9. So you see how it's kind of like taller than it normally is? That's how we know it's vertically expanded. Okay, so let's look at now these. We're actually finding the equations. I'm going to keep my calculator because you can always check your work on these. So first things first, I want you to find the vertex. Okay, and that from 0, 0 to there is going to tell us our transformation. So this is cubic. You don't have to write this on the test, obviously. This is just to show you why I'm doing what for the equation. It's increasing, so there's no reflection. The next pretty point is up 1 over 1, so there's no expansion or compression. Okay, now from 0, 0 it went over 1, 2, 3, left 3. And then it went down 1, 2, 3. Okay, so I know it's cubic. So I'm going to have x, since I have a left or right change, I have to have the set of parentheses. Left 3, remember IHOD is opposite, so left 3 is negative 3, so it's going to be plus 3. And then down 3 is exact, so it's minus 3. Oop, don't forget your y equals or f of x equals or something like that. Technically, we should do f of x. Okay. So on my calculator, I can type that x plus 3 minus, oop, don't forget to cube it, minus 3, and hit graph, and it looks pretty similar. So that is the same. Okay, let's look at number 8. I was about to say number 2. So here's my vertex. Okay, it's increasing. It's also cubic. So there's no reflection because it's increasing. The next pretty point, you see how that's not really a pretty point, but if I go up 2 over 1, that one's perfect. So I have an expansion vertically of 2. And I also know it went from 0, 0, it went 1, 2, 3, 4, 5. And then down 1, 2, 3, 3, 4, 5. Nope, that's 6. Sorry, I can't count. It's hard to focus when I'm looking at the screen. So I get f of x equals cubic. It's expansion. It's increasing, so it's going to be 2 x right 5. So right is positive, so I'm going to say minus cubed down 6. And I again type that. Oop. And it looks similar, therefore I know I should be correct. So let's look at number 9. Again, it's cubic, but this time it's decreasing, which means there's a reflection I always do a reflection over x, so an outside change. Okay, here's mine. So it only went down 5. It did not shift left or right. And my pretty point's up 1 over 1, so there's no expansion or reflection. So f of x equals negative x. Technically, I didn't need the parentheses, so I could have just written this negative x cubed minus 5 to have it to do the parentheses. Okay, so negative x to the 3rd power minus 5, which looks the same. Okay. Now we're looking at cube root again. Okay, so here's my vertex. Remember, it's kind of in the middle of like the flat spot or the upright spot or whatever, depending on which kind of graph it is. Okay, it's decreasing. So first off, cube root. It's decreasing, which means there's a reflection. Okay, it goes up 2 over 1, which means there's an expansion of 2, and we know that we deal with vertical expansions. Okay, and it went left 3, down 4. Okay, so cube root reflection. So I know I'm going to have a negative 2 in the front because reflection and expansion, so that's those two changes. Then I'm going to have a cube root. And left is on my inside change. Remember, left to right is my inside change, so it's opposite. Since I went left, that's negative, so I'm going to say plus 3. And then down 4 is exact, so minus 4. And again, negative 2, math 4, x plus 3, outside minus 4. It looks similar, so there's my answer. Okay, here's my vertex this time. So again, cube root. This time it's increasing, so there's no reflection. It went up 1 over 1, so there's no expansion or compression. It went up 4, right 3. Okay, so there's nothing in front because there's no reflection or expansion. There is an inside change of right 3. So that's positive, so I'm going to put minus, because remember, inside's exact, or opposite, outside's exact, so up 4 is plus. Math 4, x minus 3, plus 4, second graph, or sorry, graph. Looks similar, so there's my answer. Lastly, on number 9. So here's my vertex. It goes up 1 over 1. It's increasing. It is cube root. It went left 8 and down 7. Right? 8, 7. Yes. So f of x equals cube root x plus 8 minus 7. X plus 8, minus 7, which looks similar, so there's my answer. Alright, done with graphs, or done graphing, which is exciting. Okay, so it says give an example of a cubic and a cube root table. So it's asking us to produce a parent function. If I'm given, so this is cubic, which is x to the 3rd power, which is what it tells us to use. X to the 3rd power, second graph. I pretty much get 0, 0, 1, 1, 2, 8, 3, 27. So remember, that's for my calculator. Now remember, cube root is the inverse of that. So 0, 0, 1, 1. I'm just flipping. 8, 2, 27, 3. And you could type that in your calculator. You will get the same thing. Okay. Find the inverse of the following function. So I'm given this. Look at y equals 27 cubed, x cubed plus 3. I realize h of x just means y. That's why I do that, because with inverse we switch our x and our y, and then we solve for y. So I'm going to subtract 3 from both sides. Get x minus 3 equals 27y cubed. Now I've got to get rid of the 27. I've got to get y cubed alone. This cancels. I get y cubed equals x minus 3 over 27. Now I have to get y alone. Ooh, sorry, you can't see that. So I'm going to cube root both sides. This cancels that, and I get y equals. But I always need to check to see if I can simplify the bottom. So math 4, 27, that gives me 3. So I can simplify the bottom, so I'm just going to put the top in the cube root over 3. See how the difference, how this is in the house, the bottom is in the house, but here it's only on the top. Okay, the bottom is not in the house. Okay, number 15 says find the inverse of the following function and give the table for each one. So remember, this is the same thing as y, so let's find the inverse. So first things first, we need to get rid of addition or subtraction. So subtract 4 from both sides. Get x minus 4 equals cube root y minus 2. Okay, I have to get rid of the cube root before I can move the 2. So cube cancels cube root. So I'm cubing both sides. Cube root cancels cubed. This stays the same. And I'm going to add 2 to both sides. So I get y equals x minus 4 cubed plus 2. So if I type in the original in my calculator, I get math 4 x minus 2 plus 4, second graph. So I'm just going to make a table of these 3 points. So this is the original. I'll say g of x. So I get 1, 2, 3, 3, 4, 5. Okay. Now when I type the inverse in, x minus 4 to the third power plus 2, I should get those exact points except opposite. 3, 4, 5, 1, 2, 3. I do. So remember, inverse is written with the -1. Because remember, x and y just flips. Okay? Awesome. Let's look at number 16. So on here we're solving for x, so you're solving the square root functions. So I need to get this cube root functions. I need to get the cube root by itself. I've got this -3 in front. There's no symbol in between, so I'm dividing. This cancels, and I get cube root 5x plus 11 equals, so use your calculator, -18 divided by -3 gives me 6. Now I have to cube both sides to get rid of that cube root. Okay, cube root cancels cube, and I get 5x plus 11 equals, well, what's 6 cubed? 6 to the third power is 216. Minus 11 on both sides. So 216 minus 11 is 205. Divide both sides by 5. 205 divide 5 is 41. X equals 41. So there's your answer. Remember, fancy brackets. Remember, there is no extraneous. Okay? So let's look at number 17. I'm going to subtract 28 from both sides. Always get rid of addition or subtraction first. Okay, then I have this 4 in front. That's no symbol in between, so I'm dividing both sides by 4. -28 divide 4. Be careful because a lot of y'all mess up with your negatives. Oop, -7. Cube both sides. Cube root cancels cubed, and I get 3x plus 49 equals -7 to the third power. Oop. -343. Subtract 49 from both sides. Gives me -392. divide both sides by 3, and it gives me a super ugly decimal. So remember, we leave it as a fraction. So you can at math enter, and it's negative 392 over 3. There is a negative there, sorry. Alright, look at number 18. So again, we get rid of addition or subtraction first. And I get 4 cube root x plus 3 equals negative 8. Divide both sides by 4. I get cube root x plus 3 equals 2. Negative 2, sorry. Now I'm going to cube both sides. And I get x plus 3 equals negative 8. Minus 3, minus 3. Be careful here. A lot of y'all make a mistake here. Negative 8 minus 3 is negative 11. Okay, if I borrow $8 and I borrow 3 more, I get negative, I owe you negative 11, or I owe you $11. Okay? Think if somebody takes away and takes away more, that's still taking away. Okay, here. Plus 2, plus 2. I get 3, or cube root 3x plus 5 equals 2. Cube both sides, and I get 3x plus 5 equals 8. Minus 5 minus 5. 3x equals 3. Divide by 3, divide by 3. A lot of y'all mess up with this too. 3 divided by 3 is 1. So x equals 1. There's your answer. In just a second, I'm going to remind you on how to check your work. I haven't been doing that, and we should, especially on the test, the problems that aren't multiple choice. Minus 6, minus 6. Always get rid of addition or subtraction first. Divide both sides by negative 6, because that's no symbol in between. Gives us 3. Cube both sides and get 2x plus 13 equals 27. Sorry about that. Okay, subtract 13 from both sides and get 2x equals 14. Divide both sides by 2 and you get x equals 7. Okay, number 21, you're going to cube both sides. Cube root cancels cube, cube root cancel cube. You get 6x minus 3 equals 2x plus 15. And we get all the x's on one side and all the numbers on the other. So minus 2x minus 2x. 4x minus 3 equals 15. Plus 3 plus 3. 4x equals 18. Now divide. And technically you get 9 over 2 or 4.5. I don't mind which way you write it. Since it's a decimal, a simple decimal, you may write it as a decimal. Okay? Now just a reminder on how to check these. Let's check number 20. Oops, sorry. Negative 6. Math 4. 2. Not x, because we said x is 7. Plus 13 outside the house plus 6. Press enter. It should equal negative 12, and it does. Therefore, it is correct. Okay? I think I did this one in most classes, but we'll talk about it. So we have the cubic parent function and the cube root. Okay? What's true about these? Well, they're both increasing. Both of them have the same domain and range. Remember I said that's my favorite thing about cubic and cube root is their domain and range is always negative infinity to infinity. And that's your domain and your range. Okay? And then their vertex is both at 0, 0. So those are the main ones that I want you to know. Okay? So let's flip. Okay, last page. The parent cubic function here is shown on the left and the transformation of the function on the right. So really I just want to know from here to here, how did it change? So it went right 4, down 5. It did not reflect because they're both increasing, and it's up 1 over 1, so there's no expansion or compression. So that's all that it changed. Here it says the edge length of a certain cube is defined by the function e of cube root v, where v is the volume of the cube. Estimate the length of the cube if the volume is 290. A lot of y'all struggle with this one because it's simple. If v equals 290, that means I can plug in 290, and then there's no unknowns, so I can just do cube root of 290, and it gives me 6.62 if I round to the 100th, and there's my answer. Your test will tell you what to round to, or it'll be multiple choice. Okay, number 25. Marco's claimed that the inverse of the function y equals cube root x minus 5 is the function y equals x plus 5 cubed. Which equation below will help verify? So I remember telling all this. You can plug one into the other either way and solve, and if it equals x, then it verifies it's a inverse. So here, the first one has this plugged in there. Okay, cube root cancels cubed, and we get x plus 5 minus 5. Well, plus 5 minus 5 is 0, so I get x alone, which verifies that it's inverse. Here, negative 5 plus 5 cancels, and I get 3 cube root x cubed. Well, cube root cancels cubed, and I get x, which also verifies. So both a and b verify that it is inverse. I want you to realize on the second one, he plugged this one inside of there. So you can plug it in either way and see if it all cancels out, and if it does, then it is in fact an inverse. 26. Jason graphed a cube root function y equals f of x and a line y equals 4. So f of x, y equals 4. What is the solution to the equation f of x equals 4? So f of x equals 4. So pretty much just know where they touch. And we know y is 4, so we want to know the x, which is negative 2. Last problem. Sarah solved the equation x minus 4 to the 1/3 power plus 1 equals 6. Her work is shown below. So remember, to the 1/3 power is just the same thing as writing cube root. So this is correct. Okay? She just changed how she wrote it. So we subtract 1 from both sides and we get 5. So this is also correct. Then we should cube root both sides because the 4 is underneath the cube root, so we can't move it yet. But if you notice, she added 4 to both sides. So this is where her mistake is made. She should have cubed both sides before adding 4 to both sides. Okay? So no, she did not. Okay? If there's any questions before your test, you can bring them to me before your test. Y'all can do great. Have a good night.